This video gives you a sneak peek on something what we have been working on in Strimzi for some time, and that's support for better auto-scaling of Apache Kafka clusters. I have already my Kafka cluster deployed. It's using Craft. It has 3 controller nodes and 3 broker nodes. It has also cruise control and all the other Strimzi operators and monitoring tools. When I quickly check the configuration of the Kafka cluster, you can notice some special things. First one, it's using tiered storage. In this case, it's using tiered storage based on the shared NFS-based storage. And then in the cruise control section, you can see that I have enabled the auto rebalance feature, which will automatically rebalance the cluster on scale up or scale down. This is something what's still under development and it's not released yet. Then I have the standard Kafka node pools, one for the controllers and one for the brokers. And the one for the brokers is what we will be auto-scaling with the usual Kubernetes horizontal pod autoscaler. So what you can see here is that I have the cluster running. I have the horizontal pod autoscaler here. It targets average utilization of 90%. Currently, you can see that the brokers are quite underutilized, and it will auto-scale the cluster between 3 and 5 brokers. I can also watch here the Kafka rebalance resources. I have here already one as a template resource, which will be used by the Strimzi cluster operator when the scale up or scale down rebalancing happens. And the thing we need to do now is we need to create some load. So I will create the load by deploying some Kubernetes jobs, which will run different consumers and producers. And we can see here that the consumers and producers are starting, and as they start and warm up, we should see here in the horizontal pod autoscaler that the average utilization goes up. And after some time of waiting, we should see that it starts scaling up the number of brokers in the cluster. So we can see here that now the utilization is going way up over the 90%. So the way I configure the horizontal pod autoscaler is now we will have to wait a few minutes for the autoscaling to actually happen and the new broker or brokers to be started up. So let's wait for it. So fast forward a few minutes and we can now see that the new brokers are being started. That's the brokers 13 and 14. And now we will need to wait a few seconds for them to get ready. And once they get ready, the operator will automatically trigger the Kafka rebalance that will move some of the load from the old brokers to the new brokers. So we can see that they are ready now. Now we have to update cruise control to be aware of these new brokers. And we can see that the cruise control is ready. And when I move here into the different window, I can see that there's a new proposal which was added, which is named My Cluster Auto Rebalancing at Brokers. And right now we are waiting for cruise control to generate a proposal on how the topics might be arranged. And once the proposal is ready, the operator will automatically approve it, and cruise control will start moving the topics around. So the proposal is now ready and it started rebalancing. And now it depends on how big your brokers are, how long will the rebalancing take. In general, it should be around a few minutes before it finishes. This is one of the areas where the tiered storage helps because you don't have that many data on the individual brokers, and most of the data are stored in the other tier of the tiered storage. So that makes it a bit faster, but we will still now have to wait a few minutes for the rebalancing to happen. So you can see that our rebalance now completed, and that means that our scale up is done. We can also check the topics in our cluster. where we should be able to see that they are now distributed across all the 5 brokers. So you can see here, if I move especially to the load test topic, which is what I'm using to generate the load, that they are now all over the 5 brokers. You can see 10, 11, 12, 13, 14, and so on. So that's how we can check that the rebalance actually happened. Now in my case, the load seems to be still quite high, and the rebalance didn't help, but yeah, we can now see how it works when we stop the load and see how the scale down works. So let's go to the next step and let's delete the jobs which create the load. Now we see that they are being deleted. What we should also see here is that the horizontal pod autoscaler, the load will go down again. And if we again wait a few minutes for things to settle and for the timeouts to proceed in the horizontal pod autoscaler, then we should see that it scales down the cluster again back to the 3 nodes. So we can already see that the utilization is down. So now let's wait a few more minutes again. Right, and it looks like the scale down has already started. So before the broker nodes are actually removed, we need to do the scale down to clean them up in the operator. But you can see in the horizontal pod autoscaler that the desired number of brokers is now set to 3 again. And what we can see here is that the operator automatically started the remove brokers rebalance, which is already in progress. What we don't see yet is we don't see the nodes 13 and 14 being deleted, but that's because they are not yet empty. They still have the data. So first we need to wait for the auto rebalance to complete, and only once it's complete and the brokers are empty, we can actually proceed and the operator will automatically delete the nodes. So again, let's wait for the remove brokers auto rebalance to finish. So the remove brokers auto rebalance just finished, which means that the brokers 13 and 14 should be now empty. And indeed, we can see that they are terminated and removed. We can also see that cruise control is rolled again to update the cluster configuration in it. And when I again check the topic configuration, then I should see that all the replicas of the different topics are now only on the nodes 10, 11, and 12. So that's it. That's how you will be able to autoscale Apache Kafka clusters in the future. It's not perfect yet, but hopefully we'll get there over time.